Hi, everyone. I hope this finds you well. Just a brief introduction before we get started. My name is Moses Unene. I am going to be taking you through chemistry. This morning's topic is a topic that is very important, taken for granted by a lot of people because it seems to be very simple and straightforward. And the topic that we're going to consider today is that of stoichiometric calculations, amounts of reactants and products. So stoichiometric. So basically the way we're going to tackle this is simply by explaining the principle behind what we are looking at through examples, and then we'll pick selected questions from the tutorial sheets to answer particular questions that address what we have already discussed. So let's get into it. Okay, so basically, when we have the stoichiometric calculations, the way we solve problems with regards to this, and I'll try and use both, just to mention as a by the way, um, my text as well as the writing here. Um, it's not very good, but we'll try as best as we can to sort of like save time on what we need to do. So basically, what we're going to do is the first thing that we need. Let me just use the text for now. I think that will help. So the first thing that we're going to really require to solve such questions is a balanced chemical equation. Okay. So that's the first thing that we need to have, a balanced chemical equation. From that equation, or the equation that we have balanced, the second thing that is most important as we endeavor to make our calculations in stoichiometry is secondly to use the balanced equation to take the known mass, right? And this will all make sense as we go along, so just stay with me. The known mass of a reactant. So the known mass of a reactant excuse me, or product. Let me extend this side. Okay. They say good things take time. So I'd ask you to be patient with me as we go along this, because the point that I'm trying to get at is not just to help you know the answers to particular questions, but how to solve them, right? So to convert the known mass of a reactant or product to, right, moles to moles, okay? We'll end there for now. And then the third point that is very important that we're going to be considering in our answering of questions. Okay, this is a recording, but I'm sure my email address will be somewhere. You can email me if you have a question or clarification based on what you have. So based on so we first balance the equation, and then we use the known masses of a reactant or product to make moles, and then we use the balanced equation. Okay, why is that in capital letters? I don't know why. We use the balanced equation, I'll just say EQ, right, to set up appropriate appropriate mole ratios, right? Again, I'm gonna need to extend it that side. There we go. That's the third point. And then the fourth point is to use, right, the mole ratios to calculate the number of moles, to calculate the, whoopsie, the number of moles number of moles of the desired product, right? Desired product. Okay, folks. Now what happened there? Okay, we are going to need to put that back. What I needed to do was to extend this so that it looks something like that. And then the final step that we're going to consider is for us to, sorry about that, that was my phone. The fifth and final step is for us to convert back to grams, convert from moles back to grams. Okay, so balance the chemical equation, and then we have to use the known masses of reactants and product to moles, and then use the balanced equation to set up appropriate mole ratios. And then number 4, use my highlighting here, to use the mole ratios to calculate the number of moles of a desired product, then convert from moles back to grams. Now, I'm going to be a little bit unconventional, and we will not follow the numbering in the tutorial sheet. For those of you who may not know, let me just share my screen just to show you what exactly I'm talking about. So we'll be looking, we'll just pick selected questions from this tutorial sheet for this session, just to illustrate how we can use these principles. Please take note, and I want to stress this, guys. When it comes to chemistry is built on principles. It's built on logic, and it is good for problem solving, okay? When you think about chemistry, it's in everything, it's in everyday life, from your eating, from what you use in your hair for the ladies, to when you get into a car, practically everything is chemistry, okay? So pay attention to the principles. Right, back to business. Now, tutorial sheet 1, we'll be considering question 1, okay? And then I'll go all the way down here to go to question 20. Now, I know this is unconventional, but I'm trying to prove a point here. We're trying to see how we can apply the principles that I've stated there in a way that can help us answer the questions. Then gradually, as time goes along, we'll try and answer the other questions just to help one another in the time that is available. So as I said, I will not be conventional. I beg your pardon. If that is an issue for you, that's okay. So we can start with the question at hand there. So we have iodide, yes, iodide plus hydroxide, okay, ion, giving us an iodide here, as well as an iodide trioxide and then hydrogen gas. So the question is, balance the given redox reaction by ion electron method the basic medium. Okay. So for the purposes of this particular discussion, we will just we will use a shortcut so that we can get straight to the stoichiometry part of it. But then there is a way, there is the ionic electron method that we can use for this particular one. So let me just share the screen on the white board. Okay, now it looks funny, I know. Just give me a minute. I can extend this out for us. So let's open a new page. Okay, so I will rewrite the question. Okay, my hand is freezing. I would have used freehand, but it's like at this point, it's not a good idea. It will look all shaky and not pretty at all. Trust me. So let's type. I know it might take a bit of time, but trust me, this is the best. Okay, so we have iodide. Okay, we have iodide. So iodide, okay, plus O2OH. Wait, Mr. Moses, you've forgotten the signs. Don't worry, I know. Just bear with me for now. And then on the other hand here, we did have iodide trioxide. Yes, we had, I think there was hydrogen somewhere. So add a plus, let's see, add a plus sign here. Yes, a plus sign here. And then we had a hydrogen like so, like that. And then something else I forget, but that's okay. We will fix that as we go along. Of course, there is an arrow there, right? There we go. Excellent. Perfect. Now our iodide has a 2, and then our iodide trioxide has a 3, and then our hydrogen has a 2 there. Okay, so iodide trioxide, you get it there. Here we go. And then we have the iodide going on there. Okay, and then we have the hydrogen. I left out something. Yes, iodide ion. Okay, right. Again, if there are questions or clarifications, guys, please feel free to ask. That's why I'm here. We can see, so we see each other through this. Okay. So we have our iodide there, as well as our negative charge. So there's a negative charge there. There is a negative charge here as well. Okay, folks, here we go. We are good to go. Ladies and gentlemen, assuming that this is going to be watched by ladies and gentlemen, but it's good to assume. Okay, guys, so this is the equation that we have. Now, as I was writing this equation, I was thinking to myself, maybe we should just try and kill 2 birds with 1 stone. I hope you guys are down with it, because I'm down with it. And so let's get into it. So instead of using the shortcut method, let us use the, excuse me, the normal method so that we can kill 2 birds with 1 stone. So I'll use a red pen. With my free hand, please forgive me, it's not going to be perfect. Okay, there we go. So what I'm drawing now are arrows, and the reason why I'm drawing arrows is so you will learn this later on, but it's good for me to introduce it to you using the ionic method, right? So the arrows I'm drawing here are for the oxidation numbers, and you ask me what's oxidation numbers. These are the assigned charges to given atoms in a molecule. Okay, so I'm drawing the arrows here just in preparation for the oxidation number. What are we doing? You may ask. Well, we are trying to balance our equation here. Okay, so we'll learn about this again. If there are questions or clarifications, please just ask, and we do my email. I'm sure I'll be able to respond to you like that. So first things first. We have this iodide molecule here, I2, plus OH, that is hydroxide ion there. Now this iodide, this iodide, this has no charge, has no overall charge. And because it has got no overall charge, it will have the oxidation number of 0. Okay. And then when you have a mixture of oxygen with something else or hydrogen with something else, please take note that oxygen will always have the oxidation number of -2, while the hydrogen will have the oxidation number of -1. Okay, so what I mean is for oxygen here, it's going to be -2, so I put that in brackets. So we have that going down there. And we have the +1 for the +1 for our colleague up there, like so, like that. Okay, now take note, when you multiply -2, excuse me, when you add, not multiply, when you add -2 with +1, it will give us the overall charge there, which is -1 there. Okay, the actual charge is -1. So when you add this -2 with this +1 here, it will give us overcharge. So that's actually has to be observed pretty much all the time. Okay, if when you add the two numbers there and it doesn't add up, then you are in trouble, my friend. But not to worry, practice makes perfect. So we'll start with the oxygen. Okay, so oxygen has -2. I'll put them in brackets as well so that we do not confuse the situation. And guys, I'm trying to take it slow. We have the whole year, well, kind of. So I'm trying to get us into answering the questions from a understanding point of view so that we do not lose each other going ahead, because everything builds upon the principles that we're about to learn at this time. Right, so oxygen, O3 -2, right? So when you multiply, now this is where it gets tricky, so just pay attention. We multiply -2 by 3, that gives us -6. And we know that the overall charge here is 0, so we need to put the oxidation number here for iodide in such a way that when we add them, it will give us 0. I'll say that again. So we've started straight away by adding the -2 for the oxygen there. I hope you can see that. And then we say, when you multiply this -2 by the 3 there, you're going to have -6. So -6 is the number we get when we multiply these two. So the oxidation number for oxygen, for iodine, or iodide, actually iodine, is going to be +6. So when you add, it's going to give us the overall charge of 0, as we see there on top, 0, or yeah, give us 0. Okay, there we go, like so, like that. Okay, then now here again, I said that hydrogen is supposed to be -1, right, where you have a charged molecule. But in this case, hydrogen is not charged, it will be 0 as well. Okay, if this is not making sense, just hang on, it will make sense pretty soon. And then in this case, where you have iodine by itself there without any charge, it will just be -1. So that's where we go. So just stay with me and we will be together. Okay, there we go. So now we're going to look for, since it's a redox reaction and we're using a special method, the method that has been asked there in the question, we again going to use the procedure there. So now we look at our atoms now. When you compare the iodide from here all the way to here, you notice that it has moved from 0 to +6, right? And then you have this hydrogen here, okay? It has moved all the way from here to here, so it has moved from 1 to about 0. So where you have an increase in a number, like for example, 0 to +6, we refer to that as oxidation. Don't judge me, guys. I said my hand is freezing, oxidation, and then don't judge me. I mean the handwriting is not really pretty, I know. But back to business now. So where you have 0 to minus to, excuse me, positive number to a lesser number, there is going to be reduction. Okay, there we go. Right. So I'm just showing you the longer way of balancing so that, and this comes handy because you're going to have more complex questions as you keep going along, and so on and so forth. Okay, so what we'll do now is we will take, we will split the two. We'll take the half reactions. So we'll say here, oxidation, 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 and then we have reduction. Okay, reduction. Okay, what is under oxidation? So under oxidation, we have I, I'll add the 2 later. Then we make some space. Then we have IO3. You have to get used to that. That's chemistry for you. Chemistry has a very interesting aspects about it, which you will grow to love, provided you do the work. So we have the iodide there, like so, like that. Perfect. Okay, then there is a 3 somewhere. There is actually a 2 somewhere in that fashion. So we'll add a 2 there and add the 3 there. Okay. Right. So that's what we have. That's a half reaction. Okay. Then again, what is going to happen is that, I hope I'm audible enough. Then again, what's going to happen is that we're going to balance. So we first start with the, so let me remove my trusty pen. I'm going to do my best to write as nicely and neatly as I can. But if not, I'm sorry, the best I can do for now. But we'll get better. It gets better. Don't worry. Don't give up on me. Okay, so we'll start with the, oh, whoopsie daisy. We'll start with the iodide. Now, where is my pen? We'll start with the iodide. So here there are 2 elements of 2 atoms of the same element. Here it is 1, so we'll add a 2 there. Okay, and then the next thing that we're going to do, or maybe we should just take it step by step since we're trying to explain a new concept. So the first thing we're going to do, okay, there we go. We're going to balance the iodide. So I said iodide has 2 there. Then we have the O and then the 3 going on there. Okay. Then the next thing that we're going to do is balance the oxygen. And so the oxygen there, we're going to use, so to balance oxygen, you're going to use water. So how many oxygen molecules do we have? So there are 3 here plus the 2 there. That's going to be 6. So it's going to be I2. This is actually how you're supposed to answer the question. So what, killing 2 birds with 1 stone. So there are 6 hydrogen, 6 oxygen. So we'll say 6. Okay, 2 like that. Okay, then that way is going to be 2 there. IO3. Okay, so oxygen has been balanced. Then on the opposite end, we're going to add the same number of hydrogen molecules. Okay, so we have like that. Okay, so what you do is just type your question on an email or something if you have a question at this point, but I'm sure by the time we are through, you will be claro. You will be claro. Yikes. There we go. Wow, this is not as bad as I thought it would be. Awesome. This is awesome. So we have 12 hydrogen atoms. Okay, we'll bring it to the other side. So what are we doing actually? So we started by assigning the oxidation numbers, and then we are now we're now balancing the half reactions. Okay. If we have time, I'll just outline them for you, but just follow the way we're doing it. It will be clear as we go along, I promise. If not, we can still find a way to make it clear. Okay, so we have 2 iodine this side, 2, hydrogen 12, 12, oxygen 3, 6 on one end and the other end. So we now need to balance the electrons, the electrons. I've drawn the same thing down here, but maybe I can, for those of you who are trying to follow through. I see why this was put on question 20, because it's so involving. But there are other questions like this, so don't you worry. And I bet if you write this on a piece of paper, it would be way more better, more neater. Is that even a word? Neater. No, that's not a word. It would be much more neat. You know what I mean, than it is appearing here. It's great, pretty exciting writing on a mouse pad for once. Okay, so we're going to have 12 electrons here. So we balance out the thing. Just to briefly explain, so we have the half reaction there. Well, let me not take time to explain all that. We added 12 electrons here because there are 12 hydrogen atoms and we wanted to keep it neutral, just keep it original. I'll need a new page. No, we'll just use the same page. Because if you go to a new page again, that would be something else. Righty, all right. Okay, so we now go for the reduction. Perhaps I could use that same one so that I don't waste people's precious time. Okay, so the next thing that we're going to do, unfortunately, I can't copy and paste. For those of you who are computer nerds like me, I have to write. That's the goodness of Zoom. Yeah, in Zoom, you cannot copy and paste. You just have to do the work. Ooh la la. Okay, so let's get into it. So now I'm drawing the other one for the reduction. Like so, like that. Okay, of course, there is a 2 somewhere. Then there is a negative charge somewhere also. Like that. So you have the 2 there, the hydrogen, and then you have the thing. Okay. All the way there. Okay, like so, like that. Like so, like that. Right. Then I'll use my trusty pen. Let's use a different color, maybe blue, because it is a lovely blue sky outside. Okay, that was a little random, but anyway, you have to get used to that. So now hydrogen is the first one that we're going to balance. It's 2 on one end. So on the other end, it's going to need to be 2. So we have 2 there. We have OH. Then we have minus there. Then, yeah. Then we're going to say straight line there. If it's not straight, just imagine it's straight. You know the drill. Okay, and the next thing we're going to balance is, so this is a point, okay, a star. Then the next point or star, yeah. That's not a good plan. What you can do, Mr. Moses, is, okay, so put that there. Then point number 2. Yeah, those of you who like stars, you're probably feeling nice. Okay, so the next thing I'm going to do is balance the oxygen. So there are 2 oxygens here, so meaning they're going to have 2 molecules of water on the other end. Okay, if you there we go. So we have 2 there of OH. Okay, there we go. That doesn't look like an H, but that's fine as long as you're hearing the sound of my voice. 2 H like that, plus water. You know, if you are like, okay, someone I know, you pronounce it water. 2, if you're from some part. Okay, so 2 molecules of water there. Okay, so okay, then on the other end, we're going to add our hydrogens. Okay, so we say, whoops. So we have 2 there, 0. Okay, like that. So we have got 2 molecules of 2 atoms of hydrogen on one end. On the other end, they're about 6. So we're going to add 4 molecules of water or water. Okay, don't worry, I pronounce it water. The water thing is just me becoming excited. Right, so 4 hydrogen atoms there. There we go. Then we have, okay. Okay. Right. Then the last step is going to add the electrons on this side. So our electrons would be, okay, so they are minus charge there. Okay. Then we're going to add the 2 electrons there so that we cancel out the positive. Okay, there we go. Excuse me. 2H plus 2H. I don't know why people say H. I don't know if any of you have heard people say H. I grew up knowing it to be H. Okay, so there we go. All right. So then the next step from this point is now to balance out the electrons. If you pay attention here, there are 12 electrons. Here there are 2 electrons. So I'm going to have to multiply this. Going to have to multiply, whoops. Going to have to multiply this by 2. So that by 6, excuse me. Okay. So that we finally have 12OH. Okay. 12OH minus plus 24 hydrogens like that. Okay, then we have 12. Okay, electrons. Then this will be 6 hydrogen molecules, and then 12 water molecules, right? This will be 12 water molecules, like so, like that. Okay. Then the next thing that we're going to do is we're going to take, let me just show you something. So next thing we're going to do, we're going to take this, whoops. So next thing I'm going to do is going to take this structure. Let me just use my marking pen. We're going to take this right here, and this half reaction that we've balanced as well on this end, we're going to add them together. Once we add them together, you should have seen me, I was actually clasping my hands. We're going to add them together, and then we come up with our final balanced chemical reaction. Okay, then hopefully we can do the other one as well. Okay, so let's just check. So this one, we have 2 there, we have 2 there, that's good. We have 12, we have 12, that is very good. We have 6 on this side, we have 6 on this side, that's very good. And here we have 12 oxygens. On the other side, we have 12 oxygens, that's very good. 24 hydrogens. Here we have 12 plus 12. Okay. Right. And then we have also got the electrons here in that particular way. So here we have 12 times 2, that's 24. Then we have this going on here. I see. So the problem here was actually supposed to be, yes. So here it's supposed to be 2. Okay. Yeah, it's supposed to be 2 so that it is something else there. Okay. So we have, so it's important to check your half reactions, because if you don't, then that's a big problem. Okay. So 2, 2. Supposed to be 4 there. Supposed to be 4 there. Supposed to be 4 there. Okay. So here we have, excuse me. So here we have the 12 hydrogens, right? Let's do that. So we have 12 oxygens plus 24. That's going to give us 36. Okay. Then here we have 12 hydrogens, and then we have 24. That's going to give us 36. And then we have the O there. So we're actually good. Sorry about that. So it's actually fine the way it was. We shouldn't worry about that. Okie dokie. Then we can now bring our reactions together. I think I want to be a little bit more neat this time round. Okay. So we have I2. Okay, so let's use our red pen. So we have I2, okay, plus 6 6 molecules of water. Okay. Then it's going to give us 2 molecules. So this will be, that's too long. Maybe we can make it a little shorter, like that. So that we have, is it 2 molecules? Yes, 2 molecules of IO3. So 2 molecules of IO and 3. Okay. Then we have 12 molecules of hydrogen. So we have 12 molecules of hydrogen. Okay. Like so, like that. Plus, what else do we got? 12 molecules of electrons. So 12, let's just say 12 electrons. And there we go. Then we come back to our blue pan, where we have 12 molecules of OH. So we're going to say minus, excuse me. So we're going to have 12, okay, so 12 molecules of, that's not 120, it's 12 molecules of OH. Okay. Then we have 24 molecules of hydrogen. So plus 24 molecules of hydrogen, like that. Okay. Then this would be forwarded to, oh, no, 12 okay. Where is, there we go. Okay, so 12 molecules of electrons. Okay, forwardly, we have 6 of those hydrogen molecules, like that. Okay, then 12 molecules of water. Okay. Like so, like that. Okay. Then what we'll do now is we are going to add these two to the different color, maybe green, because green is a nice, beautiful color. Right. Okay. Then we say, put our positive charge there, like so, like that. Okay. I'll still use green. So oops, sorry about that. So we have the cancellation of the electrons here. Okay. Then we add now. So at the bottom here, we are going to have an iodide molecule there, plus, so 6 molecules of water, 12 molecules of water. Okay, so it means that on this end, on this side of the reaction, on the reactants, we will not have, because when you subtract 12 from 6, you're going to have 6, and 6 is going to come here and not this side. Here we have 24 molecules of hydrogen. Here there are 12. So here we will have 12 as well, right? Okay, So 12 H plus. Then we're also gonna have 12. Now I see why this was question 20. It was much longer than I thought it would be, but anyway, I'm sure it has been beneficial for somebody. Okay. Then we have the 06. So please take note, this hydrogen gas, it's different from this ion, this hydrogen just got an ion. The reason is because this one is in gaseous form. Well, no, that's not the reason. The reason why they're different is because, yeah, I think that's a better way of putting it. This is in gaseous form and this one is in ionic form, so they're very different. So just know that. Okay. And then we're going to have now our 6 molecules of hydrogen. Okay, of water, excuse me. Okay. Plus IO3 Okay, so this has been taken care of, that's been taken care of, that's been taken care of, that's it. Okay, so we have, let's see, so 2 molecules of iodine here, 2 molecules, that's balanced. Then we have 12 plus 12 there, that's going to be 24. So this is 12 plus 12, 24. Then we have 12 molecules of oxygen. So we have 6 here, and then we have 6 here, that's balanced. So this is a balanced reaction of, this is the balanced version of the answer of that particular question. Okay, so we'll stop here for now, and then next time we will consider question 1. And yeah, I hope this was helpful, just to run through what we have been doing so far. So we've basically worked on the first part, which is to balance chemical equations. Oh, now, of course, when it comes to stoichiometry, we are not going to do all that work. It would be easier. In fact, most of the time, the questions will actually be balanced for you. So you don't need to worry about that at all. But we've balanced a chemical reaction, which was this one. We started by assigning the oxidation numbers, where we had 0 there. Then we had oxidation numbers, which helped us identify which one is oxidized and which one is reduced. And then basically from that point, we actually balanced the half reaction. So this end on that end. And you also take note that also when it comes to the oxidation, the electrons are always on the left, on the right-hand side, excuse me. But when it comes to reduction, the electrons are always on the left-hand side, okay? And then we came to this particular point where we added the 2 and then we had our final equation like that. So feel free to email. My email address should be here somewhere. Yeah, so thank you so much and have yourselves a lovely day. Thank you for watching, guys.